Good morning, students. So far, in the last class, we have discussed up to the what is that is structural dynamics and what is its governing principle. That is governing principle is it is mainly based on the Newton's second law. Then we have discussed about how to derive the equation of motion. In that, we have studied about the important principle, that is D'Alembert's principle. Then based on the various parameters, that is, here you can see a figure, and here this is the diagram of a representation of a dynamic system. So a dynamic system can be represented like this. So again, the system, it is of different types, that is the degrees of freedom. Okay, the degrees of freedom we have discussed. That is, if one movement is only needed to represent their motion, then it is single degree of freedom. Others or are multiple degree of freedom. So that all things we have discussed in the last class. Now our discussion is mainly focused now on the single degree of freedom. For a single degree, it will be represented like this, and for a system there are different parameters. That is, one is mass, that is represent here mass. Then other is K. K is the stiffness. That is, if I am having a column and a beam is attached, for example, if a column is like this, you can see a beam is here, there is a beam, then two columns are there, then when a vibration, when a horizontal load is applied, it will vibrate, and that vibration, it depends upon how much with stiff it is fixed to that column. So that is the importance of stiffness, K. Then C is the damping. Damping means, that is, if I am permitting the vibration, it will never continue to vibrate. It will take, after some time the vibration will reduce. That is either due to friction, either due to air resistance, etc. So if I am applying a force to a scale which is held at one hand, one side I am holding a scale and other end is free. Then if I am applying a force in the free end, then it will vibrate. But will it continue to vibrate? No, it will vibrate. The vibration will, the amount of vibration will slowly decrease. So that factor is known as damping. So for a system, for a dynamic system, there are mainly three parameters: mass, stiffness, and weight. So mass is represented by M, stiffness by K, and so from this only the main forces are, one is inertia force, that is M into A, that we have said from the D'Alembert's principle, mass M into F is equal to M into A. So here, instead of acceleration, here if X is the displacement, so here if X is the displacement, then that displacement will result in a velocity, that is represented at X dot. We will be writing like this, X dot. The next one, it is X double dot, that is acceleration. So you can see here the force is acting in this direction. Then stiffness, it will be acting in the opposite direction, that is shown here. Stiffness is K into X, that is the force. Then damping, it is C into velocity. Damping is with respect to velocity. So these are the different forces that are acting. So with these forces only, we will be writing the equation. So the equation is like this. So equation of motion, this we have discussed, that is mx double dot mx double dot plus cx dot plus kx is equal to the force applied, F of t. It is not F, that is, the force is a dynamic force only. So this is the general equation of a dynamic system. Now here we will be having two conditions are there. One is when the force is 0. When the force is 0, when F of t is equal to 0, what it is called? It is called that is free vibration. Free vibration. And when the force is not 0, it is called forced vibration. Forced vibration. Again, this free vibration, it is of two types. One is, sometimes this damping can be, sometimes damping is 0, that is C is equal to 0. In other case, C is not 0. So when C is not equal to 0, then it is known as, if it is a free vibration, that is the, for example, in this equation, let us consider first one, mx as dot plus cx dot plus k is equal to f of t. This is a general equation. So in this equation, you can see here, so this is the equation of motion, main equation of motion. And one more thing is that if it is for, this is a single degree of freedom system, SDOF system. If it is a multi-degree freedom system, the same equation will be there, but this M, C and N, these M, C, K and etc., they will be metrics. They will be a matrix. So mx dot plus cx dot plus k is equal to f of t. That is a general equation. And if it is a multi-degree of freedom system, then this m, c and k, they will be matrix, because what is a this? So this is a single degree of freedom system. So what is multi-degree freedom system? That is, here I will be having one mass. Again there will be another mass. Two masses will be there. That is multi-degree of freedom system. So there, this M will be a matrix. C also, there will be two damping. There will be matrix. K will be there. Two K will be there. So again, so matrix will be there. So that will be studying in the last module and all. Now, so here this is a thing which I have discussed. That is, now we are discussing about free vibration. That is this P of t. That is the force P of t or F of t. So in this discussion, I am using P of t only in this slides. That is P of t is equal to 0. P means force. Okay. So that is, the equation will be like this. So again, this equation, it is of two types. That is, the C can be 0. So when C is equal to 0, what we can call it as? It is a undamped free vibration. So when C is not equal to 0, what will be that? When C is not equal to 0, it will be damped free vibration. Okay, now we have to take each of these cases. So first our discussion will be on this undamped free vibration. So first of all, I am taking a general condition, that is damped free vibration. So you can just listen. Now I have to find out the value of x. That is my aim. So I have to solve this mathematically. So there is some mathematical equations are there. I have to solve this. Now you just look here. So this is the equation. So this is a linear differential equation of second order. Why it is called second order? It is x double dot is there. So here you can it is better to write like this. X, instead of the slashes, you can write double dot plus cx dot plus kx is equal to 0. So this is the equation of a damped free vibration. So I'm starting from that equation, and then I will assume that c is equal to 0, and I will find out x. So that is a thing. So here you can see, so according to mathematics, I can the general solution can be written in like this. This x is a displacement. That displacement, it is a function of time. That is a dynamic displacement. That is equal to, I am writing it as g e raised to st. That is a general equation. Now I am going to find out these values. Okay, that is, I am going to find out the solution of this equation. So that is an important thing which we need to understand. So now here, you can just see my the equation is x. My solution, I have assumed that let x is equal to g e raised to st. Now here in this equation, what is my equation? Mx double dot plus cx dot plus kx is equal to 0. Now here I have assumed that x is equal to g e raised to st. Now I can substitute in this x, I can substitute g e raised to st. Now what will be x dot? X dot is this velocity, that is dx by ds. That is if I am taking this differential, how can I take g into s e raised to st. So this is x dot, and what will be x double dot? It is the next differential. That is, I have taken the differential of this one. G into S, and S will be there. S into S, e raised to st. That is S square G e raised to st. So my x is G e raised to st. My x dot is G s e raised to xt, and my x double dot is S square G e raised to st. Now I am substituting in this equation. That is m instead of x dot, x double dot, I am substituting this. Then c into x dot and k into x dot. So this is my equation. So in this equation, you can see here I can G e raised to st is a common factor. So I can take like this. But one thing is that this equation G e raised to st, it cannot be 0. Only this term can be 0. Now I am arranging it in such a way that this equation is arranged like that. I am taking m to the denominator, dividing by m. That is, here I am dividing by m. So how can I write? S square c by m s plus k by m is equal to 0. So this is my first equation. Now here I am having a term k by m. So this is a very important term considering our problems. That is, this k by m, it is representing angular velocity. So that how it is representing angular velocity and all, it is derived by empirical equation. So by experiments and all. So that is the reason why we are going to assume this k by m as omega square. K by m, that is omega square. That is, omega is the angular velocity. Omega is the angular velocity. Okay, angular velocity. So after deriving this, I will explain why I have taken omega square and all. That you will be getting is more clear after that. Now here you can see k. So here instead of k by m, I am substituting omega square. So this is my general equation. Okay, this is my general equation. Now, but now we are mainly focusing on undamped free vibration only. So our present discussion is mainly on undamped free vibration. Undamped free vibration means the value of c is equal to 0. So in this equation, in this here, this c term is 0. So how can I write like this? That is, if c is equal to 0, that is s square plus omega square is equal to 0. Okay, that is c is equal to 0. So again, so I can take this omega to the higher side. So s is equal to, if I am taking the square root, plus or minus I omega, because it is a negative term. Minus omega, it will be plus or minus I omega. So yes, we have obtained. Now I know that what is x of t. I started from here only. X of t is equal to g e raised to st. Now I have got what is s. S I have. What is s now? It is plus or minus I omega. Plus or minus I omega. So I can write like this. That is plus omega with the plus omega one term and minus. So this term, this can be converted into g1 plus e raised to I omega t plus g2 e raised to minus I omega t. Okay, g1 e raised to I omega. It is plus or minus. So two terms I have converted. Now, by the mathematical formulas, we know that e raised to I omega, this term can be written like this. That is cos omega t plus I sin omega. So this is a relationship only. I think you have studied this in maths in your semester, or maybe you will be studying soon, or you just clear it out, because these things we will be studying in the maths. So e raised to I omega t can be written like this: cos omega t plus I sin omega t. So I am just drawing. This is the first thing. E raised to minus I omega t can be written like this: cos omega t minus I sin omega t. Okay. Now here you can see, here there is cos omega t and sin omega t. So I am combining this cos omega t terms and sin omega t terms. So here you can see what are the cos omega. If I am expanding this, I am having g1 cos omega t. So I can just write like this. So if I am rearranging this, what is g1 cos omega t? So here also I am having a cos omega t. So how can I write this again? This can be written as, if I am taking cos omega t outside, I can write like this. It is g1 plus g2. Again, next one it is I sin omega t. Here also I sin omega. So it can be, again I can write sin omega t as a common term. In that I am having I is also a constant. So I can taking I also constant. Then g1 minus g2. So this term is again converted into two equations. That is another equation, that is x of t is equal to a sin omega t plus b cos omega. So after this class you need to write this, then only you will be understanding. So a lot of equations are coming, but considering the heavy math problems and all, it is very small equations, but the way of arranging the terms you need to understand, because these terms are arranged in these ways to derive at some conclusions only. So with that knowledge only, these terms are been arranged like this. Some terms are taken common, some terms are taken common as in other term. So that thing you need to write and study, then only you will understand what is being done. So this is the equation. This is the equation, that is x of t is equal to a sin omega t plus b cos omega t. This is the general equation of undamped free vibration. Undamped free vibration. Okay. Now from this above equation, you can see here cos omega t and sin omega t, they are periodic functions. Okay, they are periodic functions. You all know they are periodic. They will be repeating. So that is the reason why here the term omega is equal to, we have assumed in the later, omega square is equal to k by m. So omega is equal to root of k by m. That is known as angular velocity. It is in radians per second. Okay. Where, what is k? K is the stiffness, m is the mass. You will be given some simple problems. You need to find out, some days omega you need to find out. Some days we will be finding out m and all, or k we will be finding out, etc. Now here, the frequency and time period. The frequency, because here in dynamic analysis we are dealing with mainly what, vibration. So when there is a vibration, there will be a frequency. There will be also a time period. Time period means after what time it will be repeating. Time period. So then velocity. So angular velocity is given by root of k by m. Then frequency is equal to omega by 2 pi. Frequency is equal to omega by 2 pi. The time period is, it is 1 by f, or that is equal to 1 by omega, that is 2 pi by omega. Okay. So these terms you need to, these equations, omega is equal to root of k by m, frequency and time period. Now, we have started from here, that is x is equal to a sin omega t plus b cos omega t. Now we need to find out this a and omega, a and b. Okay. Now here I am writing the equation, x of t is equal to a sin omega t plus b cos omega t. So this is my equation. I need to find out a and b. So from here, when time t is equal to 0 at, that is, for example, I am considering a system at time t is equal to 0. At the initial time, what will be the velocity? X is equal to, at time t is equal to 0. Okay. At time t is equal to 0, the initial displacement, it will be, I am represented as x0. Okay, x0. Then what will be initial velocity? X dot is equal to x dot 0. That is just a representation. So I am substituting in this one. At time t is equal to 0, when t is equal to 0, sin 0 is equal to, it will be again 0. So this one will be 0. Therefore, this cos 0, what is cos 0? It is 1. So, x of t, what is xt? xt is the initial distance, that is x0. xt will become x0. x0 is equal to b. So, first thing we have found out, b is equal to x0. That is the first equation. From this we have found out. Now, next one, we can differentiate. Differentiate this. I need to find out now. A I have to find out. So, differentiating this one I am differentiating. That is x dot of t is equal to, how can I write that? A omega cos omega t minus b omega sin omega t. That is written here. X dot is equal to a omega cos omega t minus b omega sin omega t. Okay. Now I am substituting. I am having, this is my first boundary condition. This is my second condition. That is, at t is equal to 0, the initial velocity is equal to x of 0, x dot 0. So in this equation, this term will be at t is equal to 0, this is 0 because sin 0 is 0. So how can I write? Therefore, a omega is equal to x0 into a omega into 1. This will be 1 at t is equal to 0. So a is equal to x dot by omega. So this equation I have obtained, b is equal to x0 and a is equal to x dot by omega. Okay, that is, I can arrange like this. X is equal to x0 cos omega t plus x dot by omega. This is b and this is a. So I'm just written. We started from x is equal to a sin omega t plus b cos omega t. So I've just written like this. X is equal to b cos omega t plus a sin omega. For the simplification only I have written like that. So from this x is equal to x, b I have obtained at x0. This is x0. This is x dot 0, x0 dot by omega. Okay. So this is the equation. So this is the equation of motion of a solution of a undamped free vibration. Undamped free vibration. Now I can you can see that both are vectors, right? That is here this represent x dot x0. This represent, let this be a and let this be b. Now here I can write that this term, the center term, let this angle be omega t. The total angle is given here. Now here the amplitude of the motion, amplitude and phase angle, this you need to understand. Amplitude is equal to, that is here, two vectors are here, that is a and b are there. Then what will be this amplitude? It will be the root of a square plus b square. Simple. That is, what is a? That is root of x0 dot by omega the whole square plus x0 the whole square. That is the amplitude. Then phase is equal to, phase, this theta is equal to, phase is represented from here to here, that is phase, that is equal to tan inverse x dot by omega into x0. Okay, that is, you can see here, this is a, this is the phase. So what this, so phase means the difference from here I am taking. So this one will be b. So that is the reason why tan inverse, this theta will be. So that is a thing which I have written here. Okay, so here, sorry, this is b, this is b. Okay, this is b and this is a. So this term will be, this is also a. So here I can write tan theta is equal to a by b, or theta is equal to tan inverse a by b. Tan inverse a by b. Where a is, a we have found out. What is a? A is equal to here x dot by it. Then b is equal to x0. Okay. So this is the representation. That is, you can see here, initially there will be a displacement. That is, if I am having a body like this, here it is a free vibration only, and I am applying, no force is there. So what is the real application of this? Because here free vibration means there will be no force. That is a free vibration. But in order to apply vibration, we will be giving a initial displacement. That is, this system, it will be pulled to the summit like this. It will be pulled. Okay, then it will be released. So that is the initial displacement. This is the initial displacement that is given here. Now we will be drawing this one. Here, then here this tangent represents the initial velocity. Okay, then this is the amplitude, and time period means from this to this, or you can if it is having another cycle, it will be like this. From this to this point, it is given by 2 pi by omega. Okay. So after this class, just go through this, write, then only you will be getting an idea. There are lot of assumptions are being made, lot of arrangements are being made, that is the equations are being arranged, etc. Because it is being derived, it can be derived only by this means. So that is the reason why we are having lot of assumptions and lot of methods are being used. So don't feel too much of confused from this, but you just write and also one thing is that in some textbooks the notations will be different. So you can either follow this or you can follow the textbooks, but anyway the method is followed in the same way. For example, in a textbook, in some textbook, here you can see this x of t is written as, instead of this they are written a e raised to lambda t. In some textbook we will be taking it as a e raised to lambda t something, or in some textbooks instead of this ab, these constant, they are using a1 a2, like that. Some changes will be there, but the general thing will be the same. Okay. And in some textbook, this instead of omega they are taking lambda or p, like that. So it all depends on the textbook. So I have an idea, the denotations only, because you will be giving the words only. So in the questions and all, so it will not be a problem for you. So while following some textbooks only, you need to have a idea in your mind. Now you can see some of the mathematical models. Here you can see a beam. Okay, here this is a beam. Here I am having a hinge, and this is a roller support. Now this can be represented like this. It will be moving in this direction. So there will be a value K, C, and force will be there. Now the next thing, what is the difference? Here a load, vertical load is given. So it will be deflecting vertically. So this is the representation. Now I think now you will be getting an idea. What is this? Representation will be downward. Now again, look at this. Here I am having a mass, 2 columns are there. So I will be having K1 and K2. It is again a SDOF only. This is a single degree of freedom system only. But here, you can see here, this is important. That is, here the K will be, here the total stiffness will be, the stiffness can be, you just understand, go through these two equations, these two figures, figure 3 and figure 4. What is the difference? Here I am having K1, K2. That is, 2 springs are attached in, what is this arrangement? Parallel arrangement. So then the equivalent stiffness is equal to K1 plus K2. But here you can see, here there is a beam is there and 2 supports are there. The 3 supports are there. So here K1 and K2 is there. Now here there is K1 and K2. Here they are arranged in series continuously. So the equivalent will be 1 by K equivalent is equal to 1 by K1 plus 1 by K2. That will be the equivalent. Okay, while doing the problems, you will understand why I am telling like this. Okay. Now let us take an example of a first problem. A weight W, 15 Newton, is vertically suspended by a spring of stiffness K, 2 Newton per hour. So K is given. find the natural frequency and vibration. Okay, a simple system is given. So here it is not given any. There is damping. There is no word called damping is in this equation. So it is a this is a undamped vibration only. So now in this class only we will be discussing on undamped. So the C value will be 0. It will not be given in this questions. So here you can see. So first thing, what is the thing I have to find out? Natural frequency of vibration. Natural frequency. So what is natural frequency? F. F is the natural. F is equal to so here items is given. W, weight is 15 Newton. Then K is equal to 2 Newton per mm. Then so I am converting this into mass. So mass is equal to divided by acceleration due to gravity, 9.81. K is equal to 2 pi into root of this. This have to be converted into meters. That is 2 into the denominator. It will be going to the numerator. So 2 into 1000. This much is the K value. Now so F is equal to omega by 2 pi. So what is omega? Omega is equal to, first one we have to find omega. Omega is equal to root of K by M. K, the value is given here. So here omega is equal to root of K by M. That is first from we have to find out F only. This is the natural frequency, omega by 2 pi. So first of all I need to find omega. So you need to convert it into the representative. That is in omega, K and M. K should be in Newton meter, M in kilogram. Okay, so here what is the value? That is omega is equal to root of, what is K? 2000 divided by M. M is 15 divided by 9.81. 15 divided by 9.81. You will be getting omega. Omega will be around 36 something. Then again this, so F is equal to this value, omega divided by 2 times pi. So from that we will be getting the answer. Now another question we can look. Find the natural frequency of the frame. This natural frequency given the length of the column. Length of this column is 3 meter. I value is that is I, and E value is given. Okay, E is the Young's modulus, I is the moment of inertia. So here you can see here no damping force is given. Therefore our values will be that is 2 springs are there, K1, K2. Here no C value, C is equal to 0. I can write like this. Now here the thing is that there is 2 stiffness, K1 and K2. So the equivalent stiffness, K equivalent is equal to K1 plus K2. Okay, K1 plus K2. Now here the thing is that we don't know what is K1 and K2. The other problem, it was given that the K value was given, but here we don't know K1, K2. For that you need to understand these values. Okay, that is here a system is given like this. A frame is given like this. A frame is given like this. It is subjected to a displacement. I'm using another color. It is subjected to a displacement. So let it be displacing by this distance. Okay, let it be x. Okay, due to vibration there will be a displacement. This x due to this displacement there will be a force, a moment will be developed, and that moment is given by here, and this is a free hinge end, this is a fixed end, this is a free end. So here the moment is given by 12 this the force is due to this displacement, a force will be generated, and that force will be acting as a couple. That will be equal to 12 EIX by L cube. I don't know whether you have studied this in your, but I think you will be studying in your structural dynamics. That is, if one end is fixed and we are applying a displacement, then there will be a moment will be developed, and that value of moment or that value of force will be equal to 12 EI by L cube into x. That 12 EI by L cube, that will be the moment, and into x will be that will be the force, and into x will be the moment. That is 12 EI by L cube into x. So either you can by heart this equation. So here you will be studying about how we are arriving this in your structural analysis. So if you are not so after studying that, it will be easier for you to understand what I have discussed here. So here, so both the values will be that is we know that K1 and K2. So K1 is equal to, so this is the force, that force divided by x. So we know that stiffness is equal to F by x. So instead of F, here I am using P. So here it will be 12 EI x divided by L cube divided by x. So x's will cancel. So what is K1 value? K1 is 12 EI by L cube. K2 is also 12 EI by L cube. Now it is series connection. So parallel connection. So it will be 12 EI plus 12 EI the L cube. So it will be 24 EI by L cube. So this is my equivalent stiffness. So for finding this only, these values, that is E and I, are being given. Okay. So that is the reason why these values are given. So then by just substitution, we can find out what is first one omega, then you can find out what is F. So that is how you can find out. Now one more problem, that is here a mass M is attached to the midpoint of a beam. The mass of the beam is small in comparison to the mass of the beam is small compared to the mass this M. Determine the spring constant and the frequency of the free vibration of the beam in the vertical direction. Okay, the beam is of uniform flexural rigidity, EI. Uniform flexural rigidity. Uniform flexural rigidity means flexural rigidity is represented by EI. Okay. Another term is axial rigidity, that is AE. So while for a beam and all, we will be mainly considering flexural rigidity. So it means that this I value is a constant. Let's say same material is only given, or same loading condition is only given. That is the meaning of uniform flexural rigidity. So here one thing is that here I am having a mass M. They have written that the mass of the beam, this beam is also having a mass. It is very small. So only we need to consider this mass M. So here I think you have studied this equation. That is, if I am having a beam like this, a load is applied, okay, then what will be the displacement? Delta is equal to WL cube by 48 EI. For a UDL it will be 5 by 384, that value. So these values you need to have in mind, because the application, because we are studying structural dynamics, so that is you need to have a very good idea about the structural analysis, the normal structural analysis. Then only we will be able to do these problems. Okay, so here this displacement is equal to W. So why I have taken displacement? That is, if I know the displacement only, I can find out the what is that? So here K is equal to W by delta. K is W by delta. So W is equal to 48 EA by L cube. In delta I can cancel out. So so K value is equal to 48 EA by L cube. Okay, 48 EA by L cube. F is equal to W by 2 pi. That is 1 by 2 pi root of K by M. So substituting K and M, I can find out what is the values. Okay. Now here, so just go through the problem. This thing. So here in this problem, you need to understand this equation. Why it is being written here. Now another problem here. Here we studied about this value k is equal to 12 VI by L cube. This thing you just keep in mind. So it will be useful in some in other problems also. So same one problem we can look. Calculate the natural angular frequency and natural period of vibration in the sideways of a frame shown. If the initial displacement is 25, initial displacement is given, initial velocity is given, that is x0 is given 25, x dot is given 25 millimeter per, that is velocity is given. What is the amplitude and displacement at time t is equal to 1? EI value is also given, E into I is given. So here you can try, we can see here as written, the two springs are here, but here the L value is different. Here you can see this is 1 meter, other is 0.81. So what is our equation? K1 is equal to 12 EI by L cube. This L value is changing. So you can find out what is L, both values we can find out. Then you can add K1 and K2. The same equation, same way we have done in the second problem. So K equivalent is equal to K1 plus K2. So we can will be getting K value. From that, omega is equal to root of K equivalent by M. Now here what is mass? Mass is written as W is equal to 30 into 10 raised to 6. So what it will be M? 30 into 10 raised to 6 divided by 9.81. That will be M. So again, so from here I can find out what is omega. Then from that omega I can find out what is time period. Time period is equal to 2 pi by omega. What is frequency? Frequency is equal to pi by 2 pi, omega by 2 pi. Now here, what are the things which we need to find out? That is the thing. So here, you need to understand the equation of motion. X is equal to A sin omega t plus B cos omega t. And this equation we have written like this. X is equal to x0 cos omega t plus x dot 0 by omega sin omega t. This equation we have derived. This is the general equation. From this we are going to find out what is the amplitude. So amplitude will be root of a square plus b square, or root of x0 the whole square plus x dot 0 by omega the whole square. Now I know what is omega. From the equation I know what is omega. So I can find out what is the amplitude. Okay. Next one, what is the displacement at t is equal to 1? So in this equation, now I know what is omega. This is this represent x dot only. This is representing x dot by omega sin omega t plus x0 by. So in this I can apply t is equal to 1. Then by just substituting omega, we have found out what is omega, 18 point something. So from that I can find out what is x. If some days you need to find out what is t is equal to 5, for example 5 seconds. So instead of t here we will be applying 5. So that is only change. Okay. So that is a way in which we can find out the value of these equation. Now another problem you can see, determine that period of vibration. Here you can see the distances are varying, 5a, 4a, 8, 6a, etc. So the only change is the main equation you need to keep in mind is k is equal to 12 EI by L cube. So this L is changing. The first thing it is 5a, then 4a. So just substitute, then addition, you will be getting the answer. Now here another one more question we can look. So this will be the last question, that is here. Here, find the natural frequency of system. The mass of the beam is negligible in comparison. So here you can see a beam is there, then a spring is attached to it and a mass is being here. the cross section of the beam is. Why the cross section will be given? In order to find out I. Okay, so here you can see 1 by k. So here what are the values? Here this beam will be the first. So I can convert into the first model. This will be my mathematical model. Sorry, the mechanical model. That is K1, then another K2 and M will be there. So K1 value we don't know. K2 it is given in question. Here you can see it is 40 Newton. So this beam will be having a stiffness. So that stiffness, let that be K1. Now that stiffness we have written K1, that will be equal to the same thing which we studied earlier. That is, if a load is being applied like this, it will be deflecting like this. Deflection is given as W L cube by 48 EA. The stiffness is equal to W by delta. Load by deflection. That is, what is stiffness? Stiffness is unit load per unit deflection. That's the reason why it is K is equal to W by delta. So what is delta? I'll write once more. K is equal to W by delta. We know that what is delta? Delta is WL cube by 48A. So 48 will be coming in the top. So I can write K is equal to 48A by L cube. Then this is also given. Okay. So now this is arranged in a series. So series, I have to find the equation. The important thing, it is not K1 plus K2. This is wrong. Instead of that, it is 1 by equivalent is equal to 1 by K1 plus 1 by K2. So by substituting this K1, K2, we can find out what is the value of frequency. So this is the topics which we need to covered in this class. That is, we started with the general equation of motion that we derived in the last class. So this is the general equation of motion, and here in that we are assuming that the value of load is equal to 0. That is, this is the equation, mx dot plus cx dot plus k is equal to 0. From that, now we are focusing only on undamped variable, that is C is equal to 0. But before that, we started from equation, that is C is there. Then again from that, here you can see, from this equation we assumed that C is 0. Then we started with the, that is undamped free vibration, and with that we have done some problems. So you just go through this video class as well as the note thoroughly, then only you will be getting an idea on why we have doing this. So the problem wise, the equations are almost same only. You can just do some problems. The same type of equations will be coming, so you don't need to worry about that. But initially there will be a lot of problems, understanding problems will be there, but you need to keep in mind that there are a lot of assumptions, because the structural dynamics, we are dealing with the dynamic nature of loading. So in order to have an idea about that, lot of assumptions are being made. That is why the main thing you need to understand is that in reality everything it is a dynamic load, and we are in the mechanics of structures, or in your MOS, or in your mechanics, etc. They are all, we are mainly studying a assumed version of dynamics. That is, static analysis can be said as a special case of dynamic analysis, where the load is constant. So that is a thing, that is the reason why lot of assumptions and lot of groupings of this constants, etc. are being taken. So today we discussed many problems also. Just go through the problems, why it is been done, and why this 12 UA by L cube, how it is arrived, that you can refer in your structural dynamics classes. Okay, so that's all for this class. Thank you.